Correct? Okay. So hello, welcome all. Okay, we are going to start this particular topic, that is reliability engineering. As we have started discussion over now, that as usual on a lighter note, I would start avoiding writing because why? Why so? My handwriting is very good, right? Isn't it? But don't do that because I'm in the other side of the table. I have been already evaluated. This is message for all the students across the world. Okay? Don't judge your faculty. They have been already passed through that phase. Nothing will happen. My handwriting is poor, good or bad, very good, exceptional, outstanding, doesn't matter. But please take care of your answer sheets. Now, as the name suggests, reliability engineering, why so it is very critical. Some of the people assume that, it's their opinion or technical evaluation, that reliability engineering is something very theoretical, is a kind of an imaginary word, and it is nothing to do with the reality of our life. When I say reality of life, we are engineering students, we are assembled here to study the different aspects of engineering, and particularly when it's a different aspects, our parameters now will be what? Reliability. Okay? We will see that whether this reliability has anything to do with the availability of the product or not, whether it has anything to do with the failure of the product or not. So when I say product, so I am talking about the life cycle of a product. Remember, okay? So let's say there is a component. You take any XYZ component. Okay? Okay. So let's say we can take a system, or we can consider a component. Okay? Component means, for example, if I will take an example of your individual elements, can I treat it as a component? Yes? Can I treat chip or your IC as a component or a system? It's a component. Okay? Much complex than these basic elements, because somehow these basic elements form together, okay, and they follow typical design characteristic to fabricate or realize that integrated circuit or chip. Am I correct? On the other hand, if I take system, can I consider any plant or system? Can we? We are a triple E group, so can we consider, how can we end up our discussion without considering power generation and supply? Isn't it? That is our personal entity, we have a copyright on it. Right? And being a triple E, you are fortunate that you people have a copyright on both the sides. Right? Okay? So, a plant, for example, aluminum plant, chemical processing plant, okay? Steel plant, any complex engineering plant, right? Where your end objective is to produce a finished product, okay? Or you are dealing with a complex engineering application, complex assembly systems. Can you give me any example? For example, your assembly line, which is dedicatedly designed to assemble your smartphones. That's not a very typical assembly line. It's 100% robotics, okay, and 100% automated. Right? Absolutely no manual interference once you start the process. Right? Then, so therefore, any semiconductor industry, okay, fabricating industry. Grid, as I said, okay. So when I say grid, so I am primarily considering the power station. So if I say power station, that means one end is your power generation, different type of power generations media. It can be hydro, it can be thermal, it can be nuclear, it can be renewable. Under the renewable, it can be large size solar power plant. Okay, it can be windmills and so on and so on. Right? And then you have a transmission grid. Clear? Your entire transmission infrastructure, then transmission substation, then you are mapping down to distribution infrastructure. Okay, considering that small distribution substations, then you are bringing down to 415 volt. Ultimately, you are bringing down to 230 volt, so that people like me can consume that particular power as per my need. Okay, okay. So we can consider that entire grid as a system. Now, if somebody is saying that, can you fix the life cycle of a product or system? What would you answer? Yes. A company who is responsible to manufacture this pen, where I can fit something on his kind of smartphone. Now, can we calculate well before mass production that what will be its life cycle? Number one. And if I can know the life cycle, let's say go one by one. Can I predict its life? No. Can I calculate, depending on your grid infrastructure, existing grid infrastructure, what will be the power availability ratio as far as your 24-hour cycle is concerned? Because you are energy consumers, remember, no? You are consuming power, but your rating is energy, no? Is it? It is kilowatt hours. So I need to check that in your region, okay, out of 24 hours, what is the reliability, okay, or what is the ratio by which I can ensure that your local distribution company TPWDL can ensure how many hours it can supply you power, it can make sure the availability of power for the end users in terms of percent. Can you? Yeah. So that is done. So can I calculate the life cycle of this product? Can I calculate the life cycle of a smartphone or smartwatch you are using? Can I calculate the life cycle of a television you are using, refrigerator or any home appliances devices you are using? No? Answer is yes. It has been calculated before you go for the mass production. Okay? And that's how the term warranty comes into the play. Okay? And this I say on record with full responsibilities. Okay? That's how the warranty term comes into the play. If I can calculate mathematically that the life cycle of this product will be 1000 hours, okay, and tentatively you are going to use on an average 2 hours in a day, because remember it's a data, okay. So maybe someone among of you is going to use 5 hours in a day, someone is going to use 30 minutes in a day, someone going to use 2 times in a week. Okay, but depending on the different recording data, because it also has a certain material which helps me to embed these text on the screen, and obviously that is not infinite. Okay, right? So this screen has its life cycle. This product through which I am embedding this text is also has a own life cycle. So if I can calculate those, can I calculate the usability of this particular pen or not? Okay, so please be noted, this pen may exist. For to me, this pen exists only if it is usable. Right? It's a simple way that the ink khatam ho gaya, so its life is gone. Rest is useless too. Either I should be in position to refill it, or it's like a use and throw kind of thing. Okay, I'll throw it out and I'll buy a new. Correct? So now you tell me, okay, can I calculate its life cycle? Yes. Okay? You can calculate the life cycle of each and every man-made product on this earth. No single is exception. So if you can calculate And remember, someone among of you tomorrow is an entrepreneur, and you will offer your services, right? You will say that, sir, I have fabricated a beautiful pen. Your reputation will be like a sky high if you are going to use it. But remember that it will last only for 1 hour. I'll say that what I will do next. Sir, again approach us. We will provide you one more. So it will last 1 more. Okay? So do you think that commercially in this way things will be successful? No. Testing is different thing, but commercially will not be successful. You have to provide a lifespan of a product. That lifespan may be in hours, maybe in days, maybe in years, depending on the type of product, type of finished good. Am I correct? Okay. Now, because this somehow able to know that the life cycle of this pen is 1000 hours. Mathematically, this has been evaluated by the reliability engineering, that means the Six Sigma expert of the company. Normally the industry hire it, okay, and the corporate R&D lab they hire Six Sigma experts. Just Google, you will get idea. Okay? Now their job is to calculate this. Now if its life cycle is 1000 hours in general, and then we came to know that the same pen is going to optimally perform you for 800 hours. Understand? One, its a full life cycle is 1000 days, and its optimal performance you can get, sorry, not days, hours. I take an example, 800 hours. Okay? So 80% of the period is the optimal period of this particular pen. Okay? So what do we mean by optimal? Where you can get class performance. Okay? The top-notch performance from that particular product. Right? Now because its entire life cycle is 1000 hours and its optimal period is 800 hours, company will now offer you a warranty. And they know that this 800 hours in general you are going to use it within 2 years. Okay? So company bring this particular product into the market with saying that for third year, if you will do AMC, annual maintenance contract, okay, the annual maintenance contract charge of this particular product is 50 rupees. Say the product cost was 200 rupees and the annual maintenance charge is 50 rupees. We will be able to extend you 1 more year of performance. Okay? They know very well that it hasn't crossed its life cycle period. But somehow, because it is at the last 20% of its phase, okay, so obviously with time the chances of failure will be high or low? High. Chances of failure, I said, no? Not failure, chances of failure will high. So they are offering you with 50 rupees. It looks very lucrative opportunity. With next 50 rupees, I can ensure uninterrupted services of this particular component for next 1 year. Okay, and with the same another maybe around, if you add 40 rupees more, probably in 80 or 90 rupees, you can get the services of next 2 years. Okay, so that's how the company can maintain a separate segment, okay, along with its logistic to take care of the warranty of this particular device. That is clear? Okay. Now the second question we asked that whether this availability of the device or the failure of the probability of failure of the device that varies with time or that is a constant with time. Because if it is constant with time, then I would say that it is what? Free from? Can I say that it's independent in that case? Yeah? But if it is something is varying with time, then? That means it's time dependent? Okay. Now you please recall that under the head of mathematics, signal system, different engineering subjects, you might have studied different kind of distribution functions. Okay? Right now? So this distribution function here also we are going to use. Okay? Now do you think that every distribution function is offer you constant failure rate? Reliability, or I would say availability of a device. Okay, Now I am going to draw a very typical curve. Tell me what is this? Can you appreciate what kind of things it looks like? I think all of us is aware with this. Can you connect it with your somewhere in day-to-day life you have been used? What is it? Pallavi. Bolo. So what is it? Curve. I'm navigating bathtub. Isn't it looks like bathtub? Huh? Obviously not a very good drawing. Looks like bathtub. है ना? नहीं? This one end, another end, bottom. है ना? Do you think that this bathtub curve has anything to do with the reliability in the table? Okay. Let me see. This axis is time. Okay. This vertical axis is either I am writing lambda t or f of t. So that is the rate of failure. Okay. You can write rate of availability or reliability rate, it's up to you. Okay. But remember, I am going to use some of the term. Small f of t is going to represent your rate of failure rate. Okay. RT is going to talk about reliability rate. Okay. Whenever I will use the capital F of t or f of s, that is the distribution function. Remember. Okay. So we will use these terminologies time to time for our discussion purpose. Now come back to this curve. So with time, something I am trying to evaluate for what? Of a ability or reliability of a component or maybe a system as a whole, okay, which is a married of number of components and the complex combination of these number of components come together form a system. Okay, so I am evaluating a complex component, something like an integrated circuit. Okay, why I say component? Because everything is available on a single substrate. Am I correct? So on a single substrate, whatever the complex design was, it has been fetched, okay, and it has been offering you to us as a product, as a one unit product. So we can treat that complex chip even as a component, right? Isn't that chip is a combination of thousands of transistors and the resistive and reactive elements? Yeah. So can we say that chip is a system at certain hierarchy? Can we say the same chip a component at certain other hierarchy? Yes. Yeah. Similarly, our Hirakud hydropower plant, can we consider it as a system? Yes. Because it's a combination of number of compressing, expansion, prime movers, generating sections, conductors, stator, rotor, so many things. Okay, tens of thousands components are used. But can I say the same power plant, hydropower plant of component when I am evaluating at the power systems level? Yeah. So that decides on hierarchy. Okay? Number one, please do note this. Okay? Now whether you consider a component or a system, you see when you are going to design and manufacture, that means a fabricate a system or component. Okay, when I say system, so remember it's a commissioning or Commissioning or installation. When I say component, then it's a manufacturing or fabrication, depending on type of application, right? So what is this offering? Some rate of change is going down. That means it is decaying with time. Clear? So purposely I am writing this phase as decremental failure rate, DFR. Clear? So the rate of failure is decreasing with time. Yes or no?
Yes.
Then from the same curve I have been observed that for a definite period of time, the rate of failure is nearly constant, if not perfectly constant. So when I say nearly constant or in general constant, so obviously like in any application we are considering the tolerance band. So if something is falling within the tolerance band, we can treat it as a constant, right? So in that case on a note, I am writing at CFR, constant failure rate. So this period of the same device or component or system offering me constant failure rate. Remember, it's progressive with time. Right? The same component later on I observe as it experiences certain ages. So it is offering IFR. What do you mean by IFR? Incremental failure rate. Now the rate of failure has increased with time. Right? With time. Right? Because it has offered decrement failure rate, which phase represents it, this period, this segment represents which phase of the component? Early phase, initial phase. Okay. So can I treat this period as a born in period? A newborn baby has just entered into your world. Okay? Now take with a real life example. I deliberately say newborn baby. Okay? Somewhere you can treat, human can experience that, okay, I have fabricated something, so that's a man-made. So whether you consider newborn baby or newly designed product, remember that company is going to offer it for very first time. So it's a design and evaluation phase. Then it's a prototyping. Then you will jump to the commercial phase. And when you jump to the commercial phase, you are jumping basically doing a mass production, so that you can commercially ensure the availability of the product offered by your company to the end users, to the rest of the world. Remember? Okay? So designing, validation is another phase, mass production is another phase, but in both the cases, the chances of failure is very, very high at the initial phase of the product, when you are basically creating an environment or ecosystem to fabricate that particular product, to make the things realizable. Okay? Because you are able to physically touch or realize that particular thing at this phase onwards. Yes? Okay? So till now the product is not available to you. You know that is there, but it is not commercially available to you. Okay? In natural form, okay, we issue a new baby, but that has yet not entered into your womb. Idea is clear? So I am considering a natural example, a man-made example. Take application board. Now what is happening? There is a possibility, even in natural circumstances, that the baby can lose its life at the time of or during the period of its birth, because of the different complexities involved into the process. Am I correct? Right from issuing it to giving a successful birth. Okay? So the entire process is complex. Anywhere, due to some failure, some mistakes, okay, some wear and tear, you may be able to, you may not able to realize that particular newborn baby. You may not able to, you may be able to fabricate the product, but once you have fabricated product, at this phase, somewhere it has been failed. Okay? Now that is the product. But do you think that the company will supply you? deliberately, knowingly that the product has already been failed during the time of manufacturing? No, never, right? Because it has added to your credibility. Clear? So this phase is high failure rate and it is decreasing with time up to certain phase. So this part is burn-in period. Okay? Okay? So this burn-in period is offering you decrement failure rate. Clear? Then the baby has entered into your life. Okay? Or the company has able to offer that finished product successfully. Now once it has offered to whom? Consumers. So obviously the product will keep in its yard or it will sell to the rest of the world. Company will sell it to the rest of the world so that the product will available in the market. Clear? Now once it has been entered to this particular phase, you might have also noticed that sometimes you buy a product, right? And suddenly you experience some kind of problem and it's a very early phase of usability. You start using it and within 5 hours, 10 days, you experience certain problem. You buy a smartphone, somehow display is not properly responding. Maybe 1 into 10⁴ case, not very common, but it may happen. Possible? Okay? You buy a television set or some kind of smart device, its display is not responding. It has responded at the time of installation, but now after 5 hours, 10 hours, 20 hours of its usability, it is not responding properly. Practically possible? Okay? So that you are experiencing because of the lack of reliability evaluation done by that particular company at this phase. If it has been done, then the same segment would have been experienced by the company without in the notice of end user at the assembly line, before it fitting to the assembly line. In fact, you can say at the design stage. And it's no more magic. You have to do these kind of tasks, test again and again. Even you are kept on manufacturing and fabricating these products for the years. It's not that first time you have tested and then without test you are start offering it. Okay? There's something called random evaluations. Right? Now if company knows that my credibility is extremely high, okay, my name is everything. Clear? I may be offer you very limited products, but I will ensure that not a single product should fail because of the technical failures. Can you name some certain companies? Okay, Apple. Okay. So this ensures, because they test each and every product even after the manufacturing. Before manufacturing the design evaluation, after manufacturing the rigorous testing. So it involves man hours, right? It involves man hour for each and every product. Who will bear the cost?
Company.
End user, not company. Okay? Companies are smart enough. Whether you take Power Grid or Apple, nobody bears the cost. Please wipe out this idea from your mind. You are end user, you will buy it. If you are buying it, you will bear the cost. Okay? You want compromise in the cost? We want people like us in general. So I buy another phone, Samsung. What Samsung does? It will test randomly 5 phones out of every 1,000 pieces. These are not actual numbers. For your understanding, I am telling you. Okay? So 5 products randomly will pick out of every 10,000 pieces. Okay? So this also works for the mass scale. Let's say you are going to produce a 5 million products. So take the ratio of 5:1,000. So in out of 5 million, how many products will be tested? That is also a good number. Okay? And that also gives you idea that what will be the possibility of the early failure. But obviously much lesser than the testing every one or every alternative product what has been done by that. Getting my point? Maybe Samsung also experienced that, okay, there are 2 kind of product. One is Gyan Biswal. He needs somehow, my teacher aadmi hai, kya karega bichara? So he will buy something 5G. Abhi 5G aa gaya, so I am getting problem, started getting problem on my phone. not getting proper connectivity. So somehow I will buy. Again I will say that okay, Amazon please offer me something around 20,000. Okay? So we have another rich guy. Clear? He will say that no, sir, I will buy S23 right now. So it's 2024 January. The highest model offered by the Samsung is S23, and this lecture is not sponsored by the Samsung. Okay? This is a disclaimer. Clear? So that cost is maybe one more zero you can add at least. Right now? Tentatively, my product is 20,000, so I can add one more zero to get S23. Somewhere around that range. Okay? So obviously whose reliability will be high? S23. Why? Why? Because at the different phases of the fabrication of that particular high-end product. Now it's a high-end product, na? They ensure this. Okay? Increased constant failure rate. Remember, no company can guarantee you that the failure will never happen during its usability period. That's not possible at all. But what you can do, you can stretch it or compress this thing. Clear? Getting idea? Okay? So because of this reason, so in this period I am using the product. Okay? And the chances of failure is nearly constant. I didn't say zero, chances of failure is nearly constant. So for this to realize, here I draw a dotted line. Clear? And I am here assuming somewhere is my 0 point. Clear? So this is somewhere this lambda t is offering you a threshold. Okay? This is the threshold, and beyond which the chances of failure is there. So that means as far as that product is concerned, once it is successfully manufactured, company knows that this is the period, this is the bandwidth in terms of its life cycle for which the failure may not occur. That means chances is nearly 0.1%. 0.1%. Okay? Probably out of those 1000 hours, we have taken an example. This stress can be a initial 100 hours or initial 50 hours. Understand? Beyond that, we have drawn this curve. So initial phase is the burn-in period. What you are doing here? We are using this product, no? So we called it, this phase is useful life. Okay? Or useful period. Okay? You are using this component or system during this period of time. Okay? What about this? What about this?
With time when usability increases, the rate of failure.
Rate of failure is increasing. Okay? So it's like a newborn baby. So chances of life loss is maximum during the process of birth. Okay? Once as baby touch this physical world, okay, is in your hand, because of the different vaccination process and the progress in medical sciences, okay, in these thousands of years, we are able to ensure that the chances of life loss after birth will be negligible, okay, by ensuring or following those processes, the different vaccination drives and so and so, okay. Then that baby has grown with time, okay, it lives a definite period of time nearly with no disease or curable disease, okay, again because of this standard medical and life processes we are following, okay. You are doing some exercises, you are adopting some treatment, you are seeking some treatment if you are a little bit of sick from the medicinal experts, so and so. So with the help of this entire process, the chances of life loss is nearly constant In terms of time, very less at the bottom, okay? And then maybe you are entering into a phase of old age, okay? So relatively, let's say take an example of 70 years, 80 years. Now the India's average life is around close to 80 years, okay? You will surprise that roughly around 20 years back, the average life cycle of our countrymen was something around 60 years. Okay? People nearly lost their life immediately after their retirement. If I take considering the example of employees. Okay, at the age of 55 to 65, there is a maximum probability they lost their life. Okay? Now better lifestyle, better facilities, okay, better practices we are being adopted, okay, better foods are available, okay, different kind of resources are available to you. We are able to increase its life cycle, our life cycle, and in India it is roughly around 70 to 80 years. Now beyond this limit, a person may align, may not, but once you enter that zone, old age zone, then with time, chances of failure is increasing. Clear? So these are the three phases. Now tell me that the reliability is a function of a time or not? Is a function of time, right? Is definitely a function of time. Can I ensure, say that the reliability of product, higher the reliability is higher the availability. A company is offering you two segment of products, one's cost is very high, one's cost is relatively very low. Okay, so the higher cost is tentatively offering you the higher reliability. Can I say this? Yeah. So we will study in future that the cost function CFI, intrinsic value of cost, okay, is a basically a function of intrinsic value of reliability. Okay. So the higher the reliability definitely has a relation with the cost function. Does it mean that the high-end product will never fail? May not fail during its useful life period?
No.
It
can fail.
It can. Chances of failure is very less as compared to the second version of product, which is a cheaper option. Okay? So cheaper option is provided for the mass because mass is not in position to bear that high cost. Okay? Now both are satisfied. Both can engage in social network without a problem. Right? So reliability is a function of time. Cost function has also relation with the reliability. Reliability also ensures the availability of the product. If the reliability of a product is high, then the failure is low. Right? In other words, you can say that it is inversely proportional of rate of failure is inversely proportional to the rate of reliability. Done? So we are going to study all these things. We are going to consider certain distribution function mathematically that will help you to find out the exact life. Okay, when I say exact life, your calculation, because remember it's mathematics, okay, it's no philosophy, so your calculation will be nearly 95 to 99% accurate, including tolerance. Okay, so tomorrow you are going to become an entrepreneur. So good news is that if hire a reliability experts like me, I will be able to tell you with some good salary. So I will be able to tell you, okay, you do not want to offer salary, give me a consultancy, okay. So I will be able to tell you, sir or ma'am, this is going to be your product. I have been evaluated at the minute level, and this product can last you, okay, for this much X duration of period, okay, and the chances of availability is 99%. Clear? And then you can play your marketing game, rest of the things. You can offer warranty, you can offer what? AMC and blah blah. Okay? So around the last phase of this lecture, with one lighter note I am leaving you. Did you observe that most of your products fails immediate after your warranty cycle?
Yes, sir.
Yeah? Still you think that reliability is not a function of time? Is it surprising? It has been occur 30 years back, when we have a CRT tube based analog TV. It is true even till today. You take example of LED bulb, है ना? Company says that some XYZ, Surya, Moon, Jupiter company says that its life is 1000 hours. So roughly you are using 10 hours in a day, let's say. So 1000 hours means 100 days. So roughly I am taking it 3 months. Okay. So you use 10 such bulbs. Okay. You will see that around 7 to 8 bulbs will fail. Immediate next phase of the warranty is finished. If the warranty is 3 years, 1 day, 2 days, 5 days, 10 days, your LED bulb will go. Do you think that is just surprising coincidence? Absolutely not. Absolutely not. It has been calculated. And they know very well that how long it will last. हाँ भैया कॉमर्स भी तो चलाना है ना, नहीं तुम सारे ब्रेन वाले तो इंजीनियरिंग कर लिया, वो बेचारे क्या करेंगे? नहीं, चलो थैंक यू।